All of the families of compounds we've looked at so far have basically been true hydrocarbons, carbon and hydrogen only. I did throw in some halogens because that seemed appropriate, but everything else has been just carbon and hydrogen. However, there's no reason to have just carbon and hydrogen. You can also throw in other atoms, for example, oxygen. And oxygen, if it's placed on a carbon-hydrogen part, can also create some new classes of compounds. So probably the most common kind of oxygen-containing organic chemical is what's called an alcohol. Now, alcohol, a lot of times people think is drinking alcohol, and we're going to see that is one of the chemical alcohols we're going to talk about here in a little bit. But an alcohol really is nothing more than an organic chemical that has a hydroxyl group. Hydroxyl is an OH group. Now, oxygen, if you remember from Lewis structures, it likes to have two bonds and two lone pairs. So a hydroxyl has one bond to hydrogen and then one bond to connect to something else. And you can take that hydroxyl group and connect it to an alkyl group that creates ROH, and that's what an alcohol is, the generic representation. So there's the formula for an alcohol. Notice it's like an alkane with an oxygen on the end, no worries. And to name it, you take the YL off the alkyl group and add anol. So in the lower left-hand corner there, that's ethanol. That's drinking alcohol, by the way, the one that gets people drunk and stuff. But anyway, to name it, ethyl is the two-carbon alkyl group. Take the YL off to have eth, and then add anol, ethanol. CH3CH2OH is ethanol. Ethanol is more than just drinking alcohol. It's actually a great solvent for a lot of things in organic chemistry as well. There's a new way to name organic chemicals with alcohols. This is mostly appropriate when there's a choice where the alcohol goes. So back in the day, I would call 3 carbons with an OH off one of the end carbons, I would have called it 1-propanol. But the new way of calling it is to put the number next to the OL, similar to what we did with the alkenes, but in this case it's alcohols. Propan-1-ol would be the new way, and I don't care if you call it 1-propanol or propan-1-ol to me, but just realize they're both out there. And this is important because you could put the OH off the second carbon. So in my day, I would have called this 2-propanol, but the new way of naming this then would be propan-2-ol. These are isomers of each other, and you bet you start seeing a lot of isomers here when you start getting to alcohols and basically 2, 3 or more carbon atoms. If you take organic chemistry one day, this is going to be something important to you. I won't ask you any questions, and if you're not taking organic chemistry, you can kind of zone me out. But they talk a lot of times about primary, secondary, and tertiary alcohols. A primary alcohol is just where you have an OH, and there's only one carbon connected to the carbon that you have the OH on. Now, I'm sure that was as clear as mud. So let's look down here at ethanol. It's a carbon with an OH, so it's an alcohol, and this carbon has one carbon connected to it. So that would be an example of a primary alcohol, all right? The carbon with the OH has just one carbon next to it, primary. On the other hand, a secondary alcohol, all right, would be something like the middle one right there. So if you look in the lower part, this carbon is connected to an OH, so it's an alcohol, but that carbon has not just one, but 2 carbons connected to it. So that would be an example of a secondary alcohol. And you nailed it. If the carbon with the OH is connected to 1, 2, and 3 carbons, that's going to make it a tertiary alcohol. The reason this is important is each of those methyl groups donates electron density, and so the effects on the OH are quite drastic. And on the right-hand side are just some more examples. If you never take organic chemistry, don't worry about it. But if you do take organic chemistry, just realize this will be something coming down the pipeline to you. So here's a question you might see. It says, what's the name of this molecule? Okay, first thing to do, like always, count up your longest chain of carbon atoms. 1, 2, 3, 4 carbon atoms. That's going to be butane if it was an alkane. This is not an alkane, though, because one of the hydrogens has been replaced by a hydroxyl group, the OH, which makes it an alcohol. So butane as an alcohol would be butanol, and you think you might be done. But that OH doesn't have to be off that carbon. So for example, you could move it to the right one spot. That would be a whole different alcohol. All right. So we're going to need a number associated with it. So in the old days, what I would have done is I would have counted left to right, right to left, and I'm hoping you're getting better at this. If you count right to left, that OH is off the second carbon. So I would have called it 2-butanol because the OH is off the second carbon. But in this new way of doing things, the 2 goes right before the OL. So butan-2-ol would be the new name of doing it, and that's fantastic. If you want to get into the type of alcohol, the carbon with the OH is connected to a CH3 on the right and an ethyl group CH2CH3 on the left. It has 2 carbons. That would be a secondary alcohol. Don't worry about it, as I said, in this class, but in future classes that might be important. You can have 2 hydroxyls, 2 OHs off the molecule as well. And this creates what's called a glycol. A glycol is a diol, 2 alcohols. All right, they have 2 OH groups on them. And they're actually somewhat similar. Ethylene glycol and propylene glycol are both used as antifreeze in your car. Now, the official names would be ethane 1,2-diol, propane 1,2-diol, but a lot of times they just call them ethylene glycol and propylene glycol, and that's fine. Glycerol is an example of a compound with 3 OH groups. So propane 1,2,3-triol would be a fancy name for it, but people usually just call it glycerol. Glycerol is the same as glycerin, same name. Glycerin is the common name. Glycerol is a little bit more fancy chemistry name. And I've got some other triols down there that are available. So anyway, just realize lots of possibilities in organic chemistry. But again, if you break it down, longest chain, that's going to be alkyl, butane, octane, that kind of stuff, and you put these other substituents on it, good to go. Ethers are oxygen-containing organic chemicals as well. But while alcohols had the hydroxyl, the OH group, ethers are oxygens with carbons on both sides of them. So in the bottom down there, you can see the red oxygen atom, and there's ethyl groups on both sides. Ethyl is CH2CH3. So no problem, just another type of organic chemistry compound. Now in the old days, we used to call these alkyl-alkyl ethers or dialkyl ethers. And what I mean by that is if you look at that one in the lower left again, alkyl is the ethyl group on the left, alkyl is the ethyl group on the right. 2 ethyl groups would be diethyl ether. And that's what almost everybody calls that compound, just so that you know. And if you use this old school version, in the upper right hand corner, you've got 2 methyl groups connected by an oxygen. So that's an ether. The oxygen's between 2 carbons, dimethyl ether. On the other hand, the lower right there, you've got an ethyl group on the right of the oxygen and a methyl group on the left. Alphabetical order, you know how this rolls, but anyway, you'd call it ethyl methyl ether. So when it says alkyl ether, that's what it means. Ethyl methyl ether, spaces between them. If they're the same, then you can use dyes. But this is old school, and my students were able to tell me that, yeah, you should really start talking about the new version of ethers. Okay, no problem, and I'll admit it is kind of cool. So the new way, the IUPAC way, it's the shorter alkyl group, and you have an oxy added to it, and the longer alkyl group you call as an alkane. Okay, so I'm sure that was pretty standard and easy to figure out. Let's look at that little picture right there. This little ether, by the way, it is an ether because oxygen's in the middle of carbons. On the right side, there's 2 carbons. That would be an ethyl group. And on the left side, you have 1, 2, 3 carbons. That would be a propyl group. So the shorter alkyl here would be the 2 carbon group. That would be an ethyl group. But we're going to take the YL off and put an oxy on it. So that little group right there, the entire OCH2CH3, that becomes an ethoxy group. And on the right-hand side, 1, 2, 3 carbons, we're gonna call that a propane. That's what that means. Take the YL off and add ANE. Now, when you're doing this, you need to tell where the ethoxy group is connected. And in that picture, the ethoxy group is connected to the first carbon of propane. 1-ethoxy propane would be the name of that crazy thing. Now, in the old days, we used to fumble and call it ethyl 1-propyl ether, which works, but on the other hand, I kind of like the 1-ethoxypropane, so that's why I'm pushing it here. So shorter alkyl group gets an oxy, longer alkyl group gets A&E. And if they're the same, then you can just one or the other, doesn't matter. Here's 2-ethoxypropane. So this is also an ethoxy, an ethyl group, C2H5 with an oxygen, but it's connected to the second carbon of 3 carbons in propane. So that's why it's 2-ethoxypropane in that one, or ethyl 2-propyl ether. And what the heck, let's do another example. This is a methoxy group. It's a methyl group connected to oxygen. The methoxy group is in the middle of those 3 carbons, which is a propane, 2-methoxypropane. So you can see in the lower left-hand corner, you either get organic chemistry or you don't. It's an organic chemistry joke. Anyway, I have a coffee mug of this in my office, kind of embarrassing. But anyway, ethers are cool. A lot of cool things you can do with them. Realize there's 2 naming systems. Good to go.